All right, so we're shifting gears tonight. We're gonna move away from some of the analog and the VORs. We're gonna get into the GPS. So let the plane fly for you. We're gonna talk about GPS, and we're gonna spend just a couple of minutes at the end talking about pilotage and dead reckoning, which I referred to, I think, a couple of weeks ago when we talked about charting and the National Airspace System. We talked about pilotage and dead reckoning there. So let's get to it. All right. GPS. Satellite based. Who here does not know what GPS is and how it works in a car? Right, this is probably going to be something most people already are familiar with, right? Satellite based navigation systems tells you where you are, what your altitude is. It's got precise timing. It knows exactly where you are to within, I think, 3 feet in today's technology. Okay, 32 satellites. And I actually added the parenthetical comment here. I was able to edit the slide. 32 satellites in the constellation. You need a minimum of 24 to have the entire GPS system active, right? And have sufficient satellites to cover the Earth. But they always have 32 in the air, or try to have 31 or 32 in the air for redundancy. Okay, but we need a minimum of 24 to keep us going. Important point here, the last one talks about latitude and longitude. When you are in your car or in your plane or in your boat and you're using GPS, you may be entering, take me to this point, take me to 1302 Edwards Drive, my address. The system doesn't know what that means, right? It does know what that means, but it's got behind it, it's all based on latitude and longitude. Okay, so the GPS systems and the GPS satellites are really communicating with your equipment based on latitude and longitude coordinates. Okay, that's the backdrop. All right, we got to have several signals. Okay, skip this one, go to the next one. Okay, there we go, 3 meters. Right, when we talk about what we have to have, because we're getting a 3-dimensional position, we have to have a minimum of 4 satellites. Okay, if you're getting a 2-dimensional position, you would only need 2 satellites, but because we are in that 3-dimensional plane, got to have 4 satellites in your connected to your receiver in order to get a accurate position for your aircraft. Okay, we have the way the constellation is set. You should have access and connectivity with your equipment to 5 satellites. That gives you a minimum of 4 for your position fix, and then something that we're not really going to get into tonight, or maybe we will, called RAIN capability, autonomous information or something. It's essentially a check and balance. Okay, it's a 5th satellite that says, okay, the other 4 are good, and I can guarantee the accuracy of your signal. If you lose that 5th satellite, then it's not so sure. Okay, and that really impacts whether or not you should be flying using that equipment in instrument conditions or in VFR conditions. Okay, that's not necessarily important for any of this stuff, but good to know. All right, you can go from point to point. Waypoints are defined again by latitude and longitude coordinates. Okay, can you enter latitude and longitude in some equipment? Yeah, you can. Some of the GPS receivers will allow you to enter latitude and longitude, but generally you're going to be entering it based on what's saved in the database as waypoints or other coordinates. Okay, you got a couple of slides in here that just show what does a typical GPS receiver look like in some of the aircraft that we have. This is one Garmin one. All around here we've got volume, and this has integrated in it the communication equipment, not equipment, but the display. We've got common nav information over here. And this whole section talks about the GPS, right? Where are we going? What waypoint are we going to? What's our distance to the waypoint? What's the track? What's our ground speed? Okay, all of that information is automatically created or tracked using that GPS system in your aircraft. Again, a wealth of knowledge to help you know where you are, how long it's going to take you, and where you're going. All right, there's just another type display. He's got, I think, 1 or 2 more. They all do the same thing. It's all just more advanced avionics, some bigger monitors, bigger screens. So they all have the same functionality in the back. Right? And you can see it doesn't look a whole lot different display wise from what you would see in a car GPS if you had weather. Right? There you go. All right. Any questions so far? Okay, easy stuff. All right. By telling it where you want to go, it already knows where you are. So when you sit down in the aircraft or in your car and you fire up your GPS unit, it knows, once it acquires the satellites, it knows where you are. So as soon as you put another waypoint in there, it knows that's where you want to go, and it calculates everything you need to do to get there. What's the distance? What's the track? And how long is it going to take you to get there at your current speed? Here we go. There we go. The last point there, when we talk about the GPS and where you're going, we talked about the course deviation indicator with the VORs, right? We've got essentially the same thing on the GPS system. When you plot a course and go from point A to point B, you've got your course line and you've got a moving course deviation indicator to tell you, are you on your course or are you left or right? And you can navigate the same way as you would with the VOR, follow the needle, face the needle, right? The needle's off to the left, your course line's off to the left, turn to the left. As I'm doing this with my right arm. All right. Direct to. So GPSs have a database, and just like when you're in your car and you pick a point of interest or a POI or something that's already pre-programmed in the system, it's got some kind of identifier. And in many cases, what we want to fly to is an airport. So you would just put KMQS as the destination. The GPS system understands KMQS is Chester County Airport, latitude and longitude for that, and you just put that in. So you don't need to know latitude and longitude. You just need to know what the representation is within the GPS system. And things like airports, navigational aids, VORs, NDBs, intersections, major intersections, all of those things are pre-programmed into most GPS units. So as long as you know the name of it, you just call everything by name, program it in that way. Okay. In this case, they're all kind of similar, but he's saying, all right, I want to go to Waco. I just hit the direct button. Okay, it says, where do you want to go direct? You type in Waco and hit enter. And it knows you want to go straight from where you are to wherever Waco is, gives you that course, tells you how far and how long. Okay, pretty simple stuff. Unlike the pointer. Okay. And not unlike your GPS in your car, it's got a moving map, right? So it's going to follow you the entire course. All right, so here's some terms that we have when we talk about GPSs in the aircraft. The desired track, that's where we want to go, right? So when you put in a course from here to Pottstown, or from here to Reading, or here to Lancaster, your desired track is where you want to go. That's where you desire to go, okay? So you've got a desired track from waypoint 1 to waypoint 2. The bearing to the waypoint is where you are, what is the heading or the course line you would need to get to that waypoint. Now we've got the actual track. We talked about wind correction, right? Your actual track could be over here somewhere because the wind has blown you. The GPS knows where you want it to be, and it knows where you are. So it's giving you your desired track and your actual track, and it will calculate and tell you what that cross track error is. How far off course are you? Okay, so it's all right there at your fingertip. Okay, so if you're off track like that, you just know you got to fly back to the left, look at that course deviation indicator, make a turn back to the left and get yourself back on track. Okay, all pretty simple stuff, all automated for you.
Is it gonna recalculate to get you back on the desired track, or is it gonna recalculate for a new
It is not going to recalculate unless you tell it to recalculate. Okay, so unlike your car GPS, if you get lost, or it's gonna route you back or reroute you, the GPS knows where you started. It knows where you want to go. It's going to assume you're continuing to follow that unless you change it, right? Now, what you can do, and this might be in a slide, if you get off track, you can hit direct to again. Okay, if you know you want to go from point A to point B, you've blown off track, hit the direct to, put that waypoint in again. It will route you with a new track from your current position to your waypoint. Make sense? Mm-hmm. Okay, so you can do that over and over and over again. Again, you don't want to be off track in the first place, but that's a simple way to say, okay, I don't want to have to do a course correction and get back to my old track. Just let me figure out where to go from here and go to my second waypoint. Okay, we already talked about the wind, okay? All right, any questions on desired track, bearing, actual track, and cross track? Not terrible. Okay. There you go, as we just talked about. You have the option of going directly from your current spot to waypoint 2 instead of intercepting. Okay. And in most cases, with most of the GPSs, if I started here and wanted to go to waypoint 2, I would say direct to, put in the name of the waypoint, hit enter, and it would set everything up and I would fly that course line, okay? If I'm off course and I want to reestablish a new course to that same waypoint, in most systems, I just have to hit direct to, and it's already gonna pre-populate what that destination was. So all I have to do is hit enter again, and it knows I still wanted to go to waypoint 2, so it pre-populated that and then calculated that new track. So you don't have to start from scratch and putting in your waypoint. Yeah, we talked about the bearing. Heading you must fly to get there. Yeah, so this is all we're talking about, the cross track error and everything that's displayed on the display itself. Okay, wind correction, get you back on track. All right. Nothing different when it comes to intercepting in a GPS than what we learned in a VOR. Like if you're off course, set an intercept course or heading, intercept, and get back on track. All right. Airport identifiers. Everybody, I think we've talked about this many, many times, right? The airport identifier is either going to be on the chart, it's going to be in the chart supplement. It's only going to be listed as 3 characters in the chart supplement, but put a K in front of it. Not always. Okay. If there are numbers in the airport identifier, you're not going to add the K. Like N57 is not KN57. It's just November 57. So anything that's got 3 characters, you add a K in the front of it. K is just the US identifier for a general or an airport. Okay. And that's how you're going to enter it into the GPS. All right, all the same stuff we talked to. Fly direct, push the direct to button, use the knobs or buttons or whatever your aircraft and your equipment is equipped with. Put in the identifier of the aircraft, hit enter, and then hit enter again. In many cases, you have to hit enter a second time to actually start the navigation, but not always. Okay. And there you can see right down the right-hand side, what's your direct track or your desired track? What is your current track, your bearing, distance, and your cross track? Whenever your direct track or desired track and your actual track are the same, of course, your cross track error is going to be 0. You're on course. Okay. All right. Yeah, and they have the arrow. If you look at the CDI, that arrow is always going to be facing up because the GPS is always assuming you're going to that waypoint. It's not like a VOR where there's a reverse or a 180-degree radial to the other way from. Right, you're always going from where you are to your next waypoint in the GPS. So that arrow in the middle of the CDI was always going to point forward. Okay. All right. And again, these have many different looks. They all have a little bit different look and feel, but generally this is what you see. You see the letters en route next to the on the left-hand, bottom left-hand corner there. That's the current flight mode. That means the CDI is operating with en route sensitivity. So when you're en route, the sensitivity of that course deviation indicator is going to be different if you're than it's going to be if you're getting closer and closer and closer to your destination and in like an instrument approach. Okay, the sensitivity gets more sensitive. So if you're a mile off course and you're en route, your deviation indicator may be here. If you're a mile off course when you are closer to your destination and on an approach, you're going to be pegged. You're not going to know where you are. It's that much more sensitive. Okay.
How you show this to and from in this?
I'm sorry?
How you show the to and from,
To and from.
where you're going and where you're.
Like
flying?
the VOR.
There isn't one in the VOR or like in the VOR. It's always two. Okay. The GPS is always assuming you're going to your next waypoint, right? There is no from, because again, remember, when we're using VORs, we're flying away from a station or to a station, right? When we get to, with a GPS, when we get to our destination, it's not going to say, okay, now you're flying away from your destination. It's going to reroute you automatically to your next waypoint. So it's always two. Okay, it's a little bit different from the VOR approach.
You might be entering multiple waypoints because maybe you're gonna avoid Class B airspace or regular.
Yep.
So
Yep, absolutely. There can be many, we talked about full scale is two nautical miles or 5 nautical miles, depending on whether the equipment was approved or not, and that's just sensitivity in satellite or IFR versus VFR. But yeah, so we talk about yeah, here we go. We'll get into this a little bit more, but this is what you're asking about, right? So if we have multiple waypoints, in this particular case, we always say when you're flying GPS, follow the magenta line. Okay. Every GPS I know, from your current point, the current course that you're on is shown in purple on the display, right? So follow the magenta line. You can see here, they've got another waypoint that is somewhere out there, and the GPS is saying, oh, your next waypoint and your next leg is going to be here. You see it in blue. When you get the KCRQ, this will go away. It will reroute, or it'll redisplay from KCRQ to the next waypoint, and that leg will become magenta. Okay, so multiple legs could be, because again, you want to go around some restricted airspace. Maybe you just want to put in specific landmarks you want to fly over, right? Just to see them. Any number of reasons to put in multiple legs or multiple waypoints, but that's how they're going to be displayed. When you set up your flight plan, that's exactly what you're going to do. You're going to sit on the ground, start the airplane up, start up the GPS. You're going to go through the flight plan to add all of those waypoints and then hit go. Right? And then once you take off, it's automatically going to sequence you from one waypoint to the next to your destination. Okay. Okay. Yeah, so yeah, I don't know if I agree with this. Maybe I should turn off the recording. Once tracking the course, it is shown vertically on the map. Many GPS units, you can set the setting on your map display to either be track up or north up. Okay, so it doesn't always have to be shown vertically, right? If you're one of the people kind of like me, I always want my map to be displayed or my chart to be displayed with north up here, right? Then my GPS is going to show me going west. It's going to have a horizontal line, not a north up down vertical line. Okay, so just keep that in mind. Most GPS units allow you to set the track that you want to see. Right? All right, the to from triangle flips downward. If you've flown beyond the chosen waypoint, that's only if you've overflown the single waypoint, right? That's not when you're sequencing from one waypoint to another, to another, to another. It's going to show you that, hey, you've missed your waypoint, you gotta go back that way, okay? You missed your destination, right? But that's the only time you're gonna see that backwards flag. Okay. All right. Okay. So what this is doing, this is saying, okay, if I'm at point A, but I don't want to fly direct, and I don't know why anybody would do this, but you can do it. You don't have to fly direct from point A to point B. You can tell it, I want to take a course line that's 30 degrees off to the right and then follow that course into my destination. Okay. I've never seen anybody do it. I've never done it myself. But the unit will allow you to do that. Okay, so it's not always, it doesn't always have to be direct to.
Is it just because of wind correction?
No, because wind correction, you would want to be on the course and get back to the course. This may be if you want to avoid something, right? If you want to avoid a certain airspace or avoid an area. But if I were doing that, I would do what he said. I would just put a waypoint in from my current position to that waypoint and then turn onto the next course to my destination, right? Again, some of it's personal preference. Okay. Yeah, this is just saying the same thing. You can pick whatever you want, anywhere in the 360. And again, what you will see in your, if you program it that way, you will see on your moving map where you need to fly to intercept that course line to get back on course. Okay, just as you would see having the OBS in the upper left-hand course or upper left-hand side, your airplane's got to fly to the right to intercept the deviation indicator. It's going to be the same way. Okay.
For cross-track, what value is that? It says 4.9, is that miles or what?
It's going to be in nautical miles.
Okay.
Yep. All right, so we talked about flight plans. Okay, this is how you're going to do it. Not going to look just like this, not so animated, but you're going to, the system is going to know where you are, right? It's going to assume when you fire up your GPS, it's going to know you're at Chester County Airport. So when you start putting in your flight plan, you're going to put the next destination. Okay, several segments. Yeah, this is what we talked about before. With the 2-2 navigation, GPS for arrow references the waypoint you're going to, then it resequences to the next one, to the next one, to the next one. Okay. But you're going to enter into your flight plan just a sequence of all those different waypoints or what waypoints that you want in that flight plan. Here they display all airports, but again, it doesn't have to be airports. It can be VOR stations, it can be intersections, it can be airports, it can be intersections. And when I say intersection, it can be VFR intersections or
Flag,
I'm sorry?
the flag, stadium flag, you were saying? No. So if when you're flying about the stadium or something, they have the flag.
Oh, like a checkpoint, a VFR checkpoint, you can use that. When I'm talking about intersections, I talk about the VFR flyways, right? The V routes, right? Victor 1, 2, 3, the Victor Airways. Intersections of those Victor Airways are in the GPS, right? So you can put an intersection and fly to that intersection. So many, many different things. It's not just airports that you're flying to or can fly to. Okay. Push the flight plan button, start to enter all the waypoints. Once everything's in there, it automatically creates the legs from one to the next. Okay. Flight plan, sure, the same like with the arrow indicating. This is all the same stuff we talked about. It's always going to display in that magenta what your current leg is, and it's going to show you if you have the display that will show you what the next leg is. It will tell you, you're going to Long Beach, and your next leg is gonna be to Santa Barbara with the blue line. Okay. All right. Anybody use their automotive GPS with multiple waypoints? You ever done that? There's a lot of them you can say, I want to go to here, but I want to add an intermediate stop at here, yeah. It's all this, it's nothing, it's no different, right? It's the same kind of thing you would do on your GPS in the car. Okay. All right, fancy term, what they call it, when you get the one waypoint and it sequences the next one, called auto sequencing. That's the way the GPS is set up to fly. Okay. All right. We talked about that already. It already always shows your relationship to the waypoint ahead of you, and it should show a to destination or a to arrow. Okay, because you're navigating not just to a single point, you're navigating a flight plan, series of points, waypoints. Okay, if something happens, and here we show, if you want to fly from KSNA, Sierra November Alpha, to LGB, right? You've got a restricted area right in the middle of you right there, right? You can suspend that automatic sequencing and say, I want to fly around that restricted area. You navigate around the restricted area by pressing the OBS button. It suspends your active leg on the flight plan. Okay. Okay. You pick up a different course. And then after you've gotten around it, push the OBS button again. It takes you back to en route navigation and automatically gets you back on that leg to your next waypoint. Okay, so it's a little bit of a manual hack when it comes to rerouting, or what is it in a regular GPS? Yeah, rerouting, right? Yeah. All right. So nothing fancy here. Anything that's not clear so far? This is pretty easy stuff, right? If most people are familiar with the GPS, this is not unlike the other stuff. Okay. I talked about RAIN. There it is. My old man mind couldn't remember receiver, autonomous integrity monitoring. This is where we talked about having that fifth satellite to make sure that we have a reliable signal across all the other four, and our navigation is fit for use. Okay. If you don't have RAIN, your system may say unreliable, right? Depending on the system you have, may say it's unreliable. You can't use this GPS system at this current time for navigation. Okay. If you don't have that fifth satellite, there's just no guarantee that you're 100% accurate or within 3 meters. Okay. All right. This is all the same thing we talked about. 4 to navigate, 5 for RAIN. Okay. It says if RAIN is not available, another type of navigation approach system must be used. Again, legally, you can't use that GPS system for navigation. You can use it for what? There you go, bingo, situational awareness, right? But you can't use it for navigation. All right. Required for non-WAS GPS receivers. WAS versus non-WAS, wide area augmentation system, is just a more reliable, more complex system of equipment that you have for GPS or RNAV navigation. Okay, if your receiver is WAS capable, then you don't necessarily need that fifth RAIN satellite, because your system is better. Okay, and WAS is typically required for IFR navigation, IFR flight. Okay. All right.
How the GPS charts get updated and how frequently they get updates?
That's a great question. When you fire up, it's usually 30 days. I think it's 30 days. When you fire up your GPS system, there's going to be one of the initial screens, like the boot up screen, is going to tell you your data, this database is valid through a date, right? And it's also going to warn you that if it's beyond that date, you cannot use this database for VFR or IFR navigation, right? Again, situational awareness for VFR, but it's not quote unquote legal or it's not up to date for navigation. Okay, so the system will tell you that, and typically, all systems I know of, there's a US, not USB,
SSD,
I'm sorry,
SSD card.
yeah, a card that you take those updates and plug them into your receiver in the airplane, and it updates that database on a regular basis.
So the manual chart is 60 days, 56 days, and GPS is 30 days.
I don't quote me on the 30 days. I don't know for sure. I don't think it's 56 days, but it's more what the manufacturer is requiring for that GPS unit. Okay. But yeah, it's all gonna be, it's gonna have to be updated. Okay,
And with that, do you have to subscribe to a subscription for the maps?
Dennis, I can't answer that question. I think just by having ownership of the equipment, I think gives you the license to get the data. Like if you purchase that Garmin GPS system or unit, I think that does it. I don't know if you have to have a subscription or not. I don't have my own airplane. Somebody else programs all these. I don't care. I just get in and fly. Right? I know they need to be updated. When it boots up, I look at that date, make sure it's valid, make sure it's been updated. Other than that, yeah. So, good questions, good questions. All right. All right, we talked about this already. Okay, 32 in the air. Okay. Don't remember 7.5 degrees. Okay. Have to be 7.5 degrees above the horizon. Don't worry about remembering that. Yeah. Okay. The whole point is just to understand the more receivers you have or the more satellites you have in view, the more reliable your signal is. You need that fifth satellite in order to have that RAIN functionality, RAIN assurance. Okay. Okay. If you have a non-WAS receiver, can you use lateral navigation only? What does that really mean when we talk about lateral navigation? What do you think it means? Take a guess.
Doesn't have. Means something like it doesn't equate for the altitude.
Yeah,
so-
there you go. Lateral, meaning left and right. You know, it's reliable in a two-dimensional space, right? Left and right, but not certified or not able to tell you what is that elevation or that altitude. And it's accurate only to 40 to 50 meters. When you have a WAS capable system, there you go, both lateral and vertical accuracy to 1 to 2 meters, right? 3 to 4 feet.
Is that altitude MSL or AGL?
Good question. Who knows the answer?
I feel like if it's lateral and you're in the air, it's however many meters from the, oh wait, we're talking about the accuracy of that, or. I was thinking about the other one, the non-WAS one, sorry.
No. You wanted to know. See, elevation or altitude, is it AGL or MSL?
Should be AGL.
Huh?
Should be AGL.
AGL.
Who says AGL?
Yeah.
No, it's MSL. You're flying MSL. Because the GPS is telling you what is your altitude, MSL, right? It doesn't care. It knows if you were on the ground, it could tell you you're at ground level, but it's giving you all your elevations and altitudes in MSL. Okay. All right. Okay, yeah, we don't need to talk about this. WAS, when we talk about WAS, I talked about the equipment, but WAS is where we start getting into additional ground stations to ensure the reliability of the signal and accurate or course or corrections within the system. It's just much more complex and much more reliable, right? So having a non-WAS versus a WAS receiver and equipment for VFR flight, probably not a game changer. Okay, for IFR flight, definitely a game changer.
Can you set the GPS to magnetic north as well as true north?
In what?
Meaning is north on a GPS for airplanes is it only set or magnetic?
It's gonna be directing you in magnetic. It's gonna take the true course and convert it to magnetic, and then you're gonna have your magnetic indicator or heading indicator, it's all magnetic. Yep. Yep. Okay, what are some of the problems we have? You go out here and you fly a Cessna 172 with a G1000 GPS, and then you jump into a Piper with a Garmin 530 or 430. It's a bit different, right? Going from some of the systems to other more complex systems can be difficult, right? So you can't ever assume that when you're going to get into an airplane that has a GPS system, you're going to be proficient, right? You got to spend some time getting familiar with the avionics, meaning book study, and then getting in the air with an instructor to make sure you know how to navigate the system while you're flying the airplane. The more complex it is, the more time it's going to take to figure it out. And who's taking lessons here? I know you're doing a Piper. What are you flying?
Piper.
Okay. Anybody else? You're flying
Cessna.
Cessna, yeah. We'll get out one of these days, I promise.
I hope so.
So the way I look at the Cessna 172 with the G1000 is, for me, it's overload, right? It's a lot of information, right? It's like going 0 to 100 miles an hour from a regular 6-pack to this complex GPS system in front of you with buttons and navigation and everything all over it. So it takes time to get used to it and work your way into it. Okay. Yeah, a lot of them, a lot of GPS units, you can get an app, practice using them on your computer, on your iPad, right? Does not always have to be in the airplane. Practical application will be in the airplane, but you can get familiar with the button pushing using an iPad or a laptop. All right, he's got this in here. There's a couple of slides that just talk about antennas. Maybe this is just a good lesson to throw it into because you need to understand antennas for the written test and for your check ride. And the caveat, the disclaimer before I go into the antennas is you need to look at these, you need to understand them, but what you really need to understand is your airplane. Okay, the antennas that are on your airplane may not be exactly like this. It's up to you to understand the antennas and what they're for. ADF, we talked about ADF last week, right? Or Tuesday. Automatic direction finders with an NDB, non-directional beacon. The antenna for that can be the bottom part there. This one, you know what? Let's make this thing work for something. This would be mounted underneath the airplane, so it's got the signal from the ADF. And the other one, what this is showing, it's hard to see, that long wire. A lot of the Pipers, you will see a long wire that goes from the rudder all the way down to, or the vertical stabilizer, down to the fuselage. That's an ADF antenna, if you wonder what that long wire is. Okay. All right. That was worth a shot. All right, transponder antennas, DME antennas, distance measuring equipment, and VHF comm antennas. Transponders typically look like a fin hanging down underneath the aircraft. DME is kind of the same thing. A comm antenna is quite often a stubby antenna, maybe a foot long or a little over a foot long, mounted on the top of the airplane. Okay. Marker beacon antennas, you're not going to use these for VFR flight. They're used more for instrument flight and approaches. A lot of them are being phased out for marker beacons, but they're going to be mounted underneath as well. Look kind of like the hull of a boat. It's not the fin, right? It's this one. Okay. GPS antennas, they're almost all going to look like that. Look like a little knob sitting on top of the airplane, kind of flat. A little oval thing that sits on top of the airplane. Looks a lot like the ADF, but the ADF is mounted on the bottom. Okay. Oh, that worked. Got ahead of myself there. All right, so how far are we in? We're not even 45 minutes in. And we finished the GPS piece, right? Pretty simple course for today. Not a lot of content. Anybody have any questions on GPS before we get to the other stuff? Right.
This is probably jumping ahead, but
Yeah.
when they're talking about for instrument and they're saying that you have to be within so many meters for the WAS system, is that because like you could be in bad storm conditions and you're literally watching the computer to land.
Yeah, when you're flying instrument flight rules.
Yeah.
That essentially means the conditions are, you don't have the visibility, right? Can think of flying in the clouds, right? So you're completely dependent in instrument flight, normally, completely dependent on looking at the instruments to make sure you're going the right place. You can't see anything outside the cockpit, right? So by having that WAS system and that accuracy and the ability to fly according on those instruments and have that reliability without seeing the ground is really what you want. So that WAS capability is critical when it comes to instrument flight. Yeah,
Yeah, so when I watch videos of commercial airliners and they're communicating with air traffic control and ATC is saying fly to some, like these weird names. Weird points. Is that only for IFR or those?
No.
You can put those in.
you can put them in, yeah. So they are waypoints, right? So the controller is gonna say, when they give you your, if we just talk about IFR, right? It doesn't have to be IFR, but if they give you fly to, what's an easy one?
Funds track,
Huh?
funds track.
Yeah, like bunts, and they're all 5 characters, and they can all be pronounced as a word, but they don't always sound good and not real words. But yeah, they'll say proceed direct, you know, to some random sounding thing. That is a waypoint, and that airliner, the first captain or the captain is plugging that waypoint into their GPS in their cockpit, and they're flying to that waypoint. Okay, it's just a name. If you look at if you look at a VFR or an IFR chart, you'll see them all over it. If you look at a VFR chart, it's not unlike, remember we saw some of the checkpoints, the VFR checkpoints that had like a 5-character name in parentheses. It's kind of like that. Okay. All right. So now let's talk a little bit about pilotage and dead reckoning. I think we got a few slides here. The rest of it, I think there's one slide for dead reckoning. We may wrap this up by 7 o'clock tonight. Okay, pilotage. We talked about pilotage before. Pilotage is by using the eyeball and looking at the ground. It's that simple. If you see it on a chart, you can look for it on the ground and you're gonna fly there. Okay. It's the primary means of navigation for VFR flight. Okay, we always talk about using your eyeballs, right? GPS is good for situational awareness, but you're navigating in VFR conditions by looking outside. You're responsible for knowing who's around you and where you're going. Okay. Pilotage is great. Again, if the things that you're looking for on the ground can really be seen on the ground. So sometimes pilotage is difficult and we end up using it with dead reckoning, and we'll talk about both, okay? Okay. When we talked about pilotage before, when we were talking about the charts, we were talking about navigation. We talked about what you can see from the air, right? This is saying the exact same thing, right? Find things that you can be reasonably sure you're going to be able to see on the ground. Prominent roads, big rivers, railroad tracks if you're at a lower altitude, big lakes. Pick things that you can be assured of seeing in the air. Okay. This is the next bullet point is talking about bracketing, right? What's that mean? All it's saying, look at your chart, right? And let's say you've got a row of rolling hills off to the right side of your course, and you got a major highway somewhere off to the left of your course. Doesn't mean you have to be close to them, but what that's saying is if you're using pilotage and you get to a point where you're close to one of those barriers or one of those brackets, you're getting close to being off course, right? Or you're already off course. That's just your boundary to say, if I go farther than this, I need to fix something and get back, right? So we talk about bracketing. It's find something along your course that you know, if you cross over it, you've gone too far, okay? All right, good checkpoints, paved runways, airports with paved runways. Not so good all the time, right? We talked about that before. In fact, I was just talking to Josh, the chief flight instructor, when I got here and told him we were talking about pilotage and dead reckoning tonight. He said, make sure they know they gotta pick big airports, not little ones, right? And I mentioned Smoketown, right? Between here and Lancaster, I mentioned that in one of the earlier classes. Don't pick Smoketown. That guy's been flying for years and years and years. He goes, I can never find Smoketown, right? So you can't always be assured that you're gonna be able to see an airport just because it's on the chart. Okay? Railroads, again, if they're large enough, if they're easy to see, or through a fire break or something like that, just don't always assume that you can see them from the air unless they've got something to make them stand out. Multi-lane highways are best, major road intersections typically associated with larger roads or larger highways. Okay? Don't look for small rivers, look for big rivers, look for big waterways in general, okay, whether it's a lake or a river. Make sure it's something you can see from the air. Towns, we talked about that a little bit in detail last time. At night, look for the lights. During the day, look for the clumps of homes. Look for the clusters, which would be indicated on that VFR chart. Okay? Wind farms are actually really good. Wind farms, wind turbines are charted. You'll find them on the VFR chart. Depending on where you are in the US, when I go from here out to Ohio, there's a couple of spans where these wind turbines go perpendicular right across the turnpike, right? They're huge. Great things, and they're very easy to see from the air. They are really easy to see. That's a good checkpoint. Open pit mines, usually pretty good as well, right? From the air, you can see a big hole in the ground. That's something you can navigate with, okay? And we talk about VOR equipment, right? When you're flying near a VOR, look for that VOR radio transmitter, right? You saw what they look like, but just a big white dot with you can't necessarily see the point of it, but look for a clearing and look for a big white circle on the ground. That'll give you some reference as well. Now, if you're going to look for VOR equipment, you can probably just plug that VOR into your VOR nav radio and navigate to it without having to look for it. That's one way to see it. Okay. All right, there's a big airport. Okay, big lakes, big quarries, big roads, right? Big clover leaves, intersections, major highways. Okay. VFR checkpoints, right? Again, we talked about this when we talked about the charts. If you see the flag, right, we know that's a good VFR checkpoint. ATC may tell you to report based on that, so it's got to be visible from the air. They're the good things to look for when you are when you're looking for things on the ground. And you see right underneath it there, that identifier, you can plug that into your GPS, right? And that will guide you to that particular waypoint. Okay. Power lines, you'll see them on the VFR chart, not always good. Unless they're through a fire break and you can clearly see that fire break through the trees, you're not going to see power lines from the air. You're just not. Okay, so they're bad. Smaller airports, we talked about that already, whether, especially a grass airfield, right? If you're looking at a chart and see a grass airfield, don't even think about it, right? Unless you want to actually land there and you're close enough to the ground to be able to identify it. Small streams, small lakes, again, the smaller they are, the worse they are as checkpoints. When you're looking at your VFR chart, right, just because there's a small stream or a river, doesn't necessarily mean there's gonna be a lot of water in it, right? It could be a dry bed. You're not gonna see, it's not gonna stand out as a waterway from the air. So keep that in mind as you're looking at your places. Okay. We already talked about big towns versus small towns, right? If your town is identified by a tiny dot on your VFR chart, probably not a good idea to look for that. Unless you're in a very remote area and that little dot of a town with 15 homes is going to stick out, not in general. Individual mountains, somebody will look at the chart and say, oh, I can fly to this mountain. Okay. There's a lot of mountains out there, right? If it's a mountain range with multiple peaks, which one are you flying to, right? So be careful when you're using anything that's got a higher ground elevation, unless it's really identifiable and sticks out uniquely. Okay. We've already talked about some towers. Some towers may be in the middle of nowhere and they'll stick out quite well. Okay. If you're in the middle of a very congested or I don't say urban area, but a congested area where there's a lot of towers, it's not going to stick out. You're not going to be able to navigate. All right. Power lines, in this case, I can tell you when you're at 3,000, 4,000 feet. That may be what it looks like in the ground, but it ain't gonna look like that from the air, right? That tower, those towers are probably what, about 98% air? You're not gonna see that structure from up above, right? So be careful, be careful. All right, so that's pilotage, eyeballs. Look at the chart, look outside the airplane, look and navigate by those waypoints on the ground. Yeah,
One of the videos for today, there was a pilot who was actually showing how you would navigate, right? And he used a lot of examples, so I'm gonna go parallel highway 635.
Okay.
Now, I'm gonna intersect highway 51 or whatever. On the VFR sectional charts, you might be able to see a road, but I don't see that they show you what the number of that road is.
some do, right? So if you look at the charts we were looking at the other day, everybody had one. If you open it up and look closely, like Route 76, the Pennsylvania Turnpike, you will see the little turnpike identifier symbol with 76 in it, right? Not every road has that. Some of the major roadways do, but that's the only way you're gonna know, right? Flying around here, if you're familiar with the area, you're flying east-west, you can generally see the turnpike when you're flying out that way, right? But if you're not familiar, then you may not know the right road, right? But yeah, some of them do have the indicator, some do not. And some, we talk about GPS, right? Depending on the GPS system that you're using, that moving map, generally, you can add or remove the amount of clutter that's on that screen, right? So you can say it's going to show you obstacles, it's going to show you roads, it's going to show you intersections, it's going to show you everything. And you can hone that down and limit the amount of information. But if you're showing roads and any of those roads that are major roads that would have that identifier, sometimes that will appear in your GPS screen saying you're about to fly over Route 76, right? But again, it's all dependent on the equipment and what you have displayed. All right, other questions on pilot or GPS? I think there's only one slide here. I could be wrong. Okay. All right, dead reckoning. This is flying by the numbers, right? I call it flying by the numbers. They're using mathematics, right? This is where you're looking at weather, you're looking at charts, and you're computing where you're going to need to go to fly. And we say pilotage is used in conjunction with dead reckoning. What's wind do? Blows you off course, right? So dead reckoning is the process by looking at the weather maps, looking at the winds, looking at your course and calculating, and you'll do this next week with Kenzie, right? Calculating what's the wind correction angle, right? Based on your altitude and what the winds are going to be and what your course is, how much should you crab to the left or to the right? That's dead reckoning, using those computations to augment what you're trying to see outside and the way you're navigating the airplane. Okay. Dead reckoning is going to tell you things like wind correction angles. It's going to help you calculate your ground speed, right? If you're in the air, you know your airspeed, but if you've got a strong headwind, that's going to limit your ground speed, right? It's going to slow you down in time over the ground. Your ground speed is going to impact the time it takes you to get from point A to point B, right? So you may be cruising at 130 knots in the air, but you've got a 50 knot headwind. Your ground speed's only 80 knots, right? That's going to impact time to get to your location, right? So that's what dead reckoning is. Dead reckoning is going through all of those calculations during your pre-planning so that when you get into the cockpit, you had the cross-country planning charts, right? All that's going to be on there, right? For each leg of your trip, you're going to know what's my wind correction angle. How far is it going to take me? How long is it going to take me to get there? How much fuel am I going to burn? All that stuff goes into that cross-country planning that you're going to do next week. That's dead reckoning. Make sense? It's using those calculations to supplement the pilotage. Okay? I think. We just talked about that. Yeah, so this is all the stuff you'll do next week, right? The good thing is, when you look at these next week, they got the equations, the calculations are right on the thing. So even for your test, you got the answers, right? So, but next week, I'm glad they split the cross-country planning over 2 lessons for next week. It used to be one night, couldn't get anything done, right? It was way too much work to do in one night. So doing it in 2 nights should give you a good, depending on how Kenzie does it, should give you a good opportunity to sit down, look at a chart, plot a course, and do some dead reckoning to see how all this stuff fits together. Okay? All right, there's an example of what that, all those dead reckoning calculations is gonna look at. You can see on the left side, what are your winds that you're gonna be flying in? Winds from 200 at 5 knots, temperature 9 degrees Celsius. You got your true course, your magnetic heading, all of that stuff calculated based on the wind, right? Your true course, your magnetic heading. And then on the right-hand side, based on my ground speed, how far am I going? How fast am I going? How long is it gonna take me to get there? And how much fuel am I gonna burn to get from one point to another? Okay, that's all part of that pre-flight navigational planning. Okay. All right. We're up to slide 3. I think we already talked about that. Okay. Questions? This was an easy one tonight. Easy one. Okay. All right. What's a good checkpoint? Bravo. Dead reckoning relies on what? Alpha, as soon as you see the word calculations and a nav log, right? You're calculating and putting it all in the log to follow in the airplane. All right. Questions? Enjoy the free hour.